Right, so this evening we're going to be working through the November 2017 Numeracy Intermediate Tier Paper 2. So this is the one where you're expected to be able to use a calculator. I'll stop for the first section after question 5, which takes us into the CB grade questions. Got a nice space here where we'll keep into our good habits of writing down here all the important relationships that may well come up in this paper. In the first bit, it doesn't matter what order you do this, but I like to put my trig ratios here, because this is a paper 2, so we're almost certainly going to have a right angle triangle question where we need to use these car towers. So if I just write those down now, I don't have to worry about them afterwards. Similarly, circle questions like to crop up on a paper 2 where you're allowed to use a calculator. So area of a circle would be pi r squared. You're not given that formula. Circumference of a circle, which is the distance around the outside, is 2 pi r. So if you think both of those formulae have got a pi in them, they've got an r in them, and they've got a 2 in them, it's just the 2 is in a different place. And the other relationship with circles that is very popular in these questions on a paper 2 is volume of a cylinder. Volume of a cylinder is basically a form of that where you've got the volume of a prism. The circle is the area of cross section, which is pi r squared. And then the height of the cylinder is the length, and that gives you the volume. So volume equals pi r squared times the height is one that crops up a lot. So we've got those circle relationships. Then we've got our compound measure relationships. Speed, distance, time. Density, mass, volume. The other one is population density, which doesn't tend to be in a triangle, but we have covered population density as well. So you need to know those. Confusing there, that d there is distance in speed, distance, time. That d there is density in density, mass, and volume. Then remember those time fractions. 15 minutes isn't 0.15. It's a quarter of an hour, which is 0.25 of an hour. 30 minutes is half an hour, which is 0.5. 45 minutes is 3/4 of an hour, which is 0.75. Okay? So writing those down keeps that fresh in your memory. Because it's paper 2, we can use the time button, and there is a question in here where we'll be using that. The other relationships which you have to learn are the ones between metric and imperial. Okay? So the important ones are between kilometers and miles. And that squiggly equals means it's approximate. So 8 kilometers is approximately equal to 5 miles. 1 litre is approximately 1.75 pints, and 1 kilogram is approximately 2.2 pounds, which is lb. And the other relationship which is used a lot, and you're expected to know, which is 1 litre is equal to, this time, 1,000 cubic centimeters. So those are both metric measures. So it's not an approximation, they're the same. So that is another relationship, if we're working with a liquid volume, that we could have to deal with. All right? So the more times you write those down, the more chance you are of remembering them. And it's important that you can remember them. Okay. Question 1. Raspberries cost £3.60 a kilogram. Pears cost £2.60 a kilogram. Reese buys some raspberries and some pears. Reese weighs the fruit he buys. The raspberries cost him £4.50. So here's our first question. Calculate the mass of the raspberries Reese buys. So that's the work that we've got to do, the question we've got to answer. Now, this is quite unusual because they're using the word mass. If you go to the veg shop or the supermarket, you'd want to buy a weight of fruit, but technically the correct term is mass. When I was marking this paper, this caused a lot of people confusion because they were thinking this was a density question. It's not. All they're asking there is basically how much raspberries were bought. So the raspberries cost him £4.50 and the cost per kilogram is £3.60. So to find out the mass he bought £4.50's worth, and you want to see how many times £3.60 goes into that. Now, because this is a paper 2, you haven't got to worry about the division here because the calculator will do it for you. £4.50 divided by £3.60 equals, and then turn it into a decimal, which is the SD button, 1.25. And it's not the price, it's the weight, the mass, so that's 1.25 kilograms. Check back, have I answered the question? Calculate the mass, 1.25 kilograms, yes. Then straight away, part B is the OCW question. Now this is usually good. If this is early on in the paper, it means it's an overlap with the foundation tier. So it's quite, for you, it should be quite an easy question. Okay? So the OCW means that there are 2 marks for this question for how you organize your solution, how you explain what you're doing. He finds that the mass of the pears is 3 times the mass of the raspberries. Okay, well, that doesn't jump out at me, so I'm going to make that stand out. Mass of the pears is 3 times as heavy as the mass of the raspberries. How much change does Reese get from £20 when buying the raspberries and pears? So how much change is what I've got to answer. Right, so let's figure this then. We know that he's bought 3 times as many pears as raspberries. So he's bought 1.25 kilos of raspberries. So the mass of pears will be 3 times that. So 3 times 1.25. So he's bought 3.75 kilograms of pears. How much change does Reese get from £20? Well, to answer that, I need to know how much he spent on the pears. So the cost of the pears will be, that's how many he's bought, and they cost £2.60 for every kilogram. So it will be the mass times the £2.60. So 3.75 is how much he's bought, times £2.60, so £9.75. He really loves his pears. How much change does Reese get from £20? Well, I haven't worked that out yet, but I know he's bought £9.75 of pears and £4.50's worth of raspberries. So the change will be the 20 quid less the £9.75 for the pears, less the £4.50 for the raspberries. So 20 less 9.75 less 4.50, £5.75. So how do you earn the marks on that question? So for part A, there's 1 mark, which is a method mark for showing that you're doing a division, and you're doing £4.50 divided by £3.60, and then an answer mark for the 1.25. If you just wrote down 1.25, you'd get both marks, even if you hadn't written down the method. The method is important in case you press something wrong on your calculator. And then part B, there's a B mark. So B marks are, I'm looking for a number. If I see 3.75, you get that mark. I don't care how you've worked it out. There's a B mark for £9.75, and there's a B mark for £5.75. If you'd have worked out the total cost by adding those together, if I saw £14.25, there's a B mark for that. But because I jumped that step, I would get the 2 marks for that. So those are how the 4 marks are allocated. And then the OCW question, 1 mark is for the examiner being able to follow what maths you're doing. So mass of pairs, cost of pairs, change gets you 1 of those marks. OCW. So 1 mark for that. And then generally the other mark is for consistent units. So the fact that when I'm talking about a mass, I'm using kilograms. When I'm talking about cost, I'm using pounds. So that would give you then those extra 2 marks. Okay, so it's not to write an essay or write a story, it's just to be organized and consistent. Question 2, horrendous looking question. So this is a Venn diagrams question. Now Venn diagrams come up on both the numeracy paper and they come up on the maths paper. So these will be something that we'll be looking at in the spring term as well from a maths point of view. So the head teacher of Ysgol Maes Newydd gave option forms to all Year 9 pupils. The form asked which foreign languages the pupils would like to study in Year 10. There were 4 languages listed on the form: French, German, Spanish and Mandarin. The pupils could select as many of the languages as they wished. All pupils completed and returned the option form. The head teacher displayed the results in a Venn diagram as shown below. So the way that a Venn diagram works is, if you consider that circle there represents all the students interested in Mandarin. If they're in this part of the circle where there's no overlap, they're only interested in Mandarin. If they're in this bit here where there's an overlap, they're interested in Mandarin because they're in this circle, and Spanish because they're in the Spanish circle as well. Okay, so the overlaps tell you where they're interested in more than one subject. How many pupils did not select at least one of the 4 languages? Circle your answer. Well, if they didn't select any of the languages, they'd be outside the circles. And the number that's outside the circles is 0. So in this case, no pupils did not select at least one of the 4 languages, because all the other students are inside the circles. How many pupils are there in Year 9? So every student is represented on that diagram. So to work out how many there are in Year 9, we've got to add up all these numbers. Okay? Remember, you're allowed to use a calculator, so it isn't a mental maths exercise. And what I would do is, as I'm going, I'm going to mark off what I've typed in my calculator, just so that I know I haven't missed any. So hopefully there's a 96 there, and hopefully you agree with me there's 96. So there are 96 in Year 9. How many pupils selected only one language? So the only one language is going to be these kids, 14 there that are only in the German part of the circle. There's 7 there that are only interested in Mandarin. The 1 interested only in French, and the 2 interested only in Spanish. So we've got 14 plus 7 plus 1 plus 2, 21, 22, 24. So 24 of the students are only interested in one language. Which was the most popular language selected? You must show all your working. So in order to figure this, I've got to know how many are interested in doing Mandarin. So Mandarin is everybody that's inside that complete Mandarin circle. So it's those 7 who just want to do Mandarin, those 8 that want to do Mandarin and German, those 3, those 5, and those 22. And then we do the same for Spanish, which is 22 plus 2 plus 27. The same for French, which is 27 plus 5 plus 3 plus 7 plus 1, and the same for German. And in this question, it says you must show your working. Now that doesn't mean you have to work it out without a calculator and do carries and all that. It just means that you're showing how you're working out each one. You then use your calculator, if you wish to add them up. So 45 chose Mandarin, 51 chose Spanish, 43 chose French, and 32 chose German. So which was the most popular language selected? Well, I haven't answered that yet. I've done all the work. The most popular language was 51, which is Spanish. Part E. The head teacher can offer only 2 out of these 4 languages in Year 10. She writes the timetable so that as many as possible of the pupils who chose 2 languages are able to study those 2 languages. Which 2 languages will the head teacher offer in Year 10? So that's what we've got to figure. You must show all your working and give a reason for your answer. So, what possible combinations of languages could there be? Well, there could be Mandarin and Spanish. So so M and S. So Mandarin and Spanish, I've got those 22 are in the overlap, and that 0 is also in the overlap. So there's 22 interested, 22 interested in Mandarin and Spanish. Then there's Mandarin and German. And Mandarin and German is this overlap, which is 8 and 3, 11. So Mandarin and German is 11. And then there's Mandarin and French. So Mandarin and French are in the overlap of the Mandarin circle and the French circle, which are those 3 regions there, so it's 8. So Mandarin and French is 8. They could choose Spanish and French. Spanish and French is this part of the diagram, which is 27, because that part overlaps the Spanish circle and the French circle. So Spanish and French is 27. If you look, there's no overlap between Spanish and German. So none of the students wanted to do that subject and that subject. So there's no overlap between Spanish and German. There is an overlap between French and German. So the overlap between French and German is this circle and this circle, which is 10. So those are all the possible overlaps. Which 2 languages will the head teacher offer in year 10? So the head teacher wants to offer the 2 with the biggest combination, which is Spanish and French with 27. So which 2 will they offer? Spanish and French. You must show all your workings done and give a reason for your answer, because this has the greatest overlap. Something like that. You're basically saying more kids want to do Spanish and French than any other combination. So marks for that. Well, it's a straightforward 1 mark for 0, 1 mark for 96, 1 mark for 24. So they're all B marks. The examiner is just looking for the right answer. And then for part D, there is 1 mark for sight of the fact that you've added them all together, 1 mark for the correct Spanish total, and 1 mark for the conclusion. And then for part 2, once more, there's 1 mark for working out all those combinations, and an explanation mark for saying Spanish and French, because that's got the greatest interest or the biggest overlap, something like that. All right? So that's question 2. Question 3. Lloyd has carried out a survey in his school. He surveyed 300 pupils. Below is a section from his questionnaire. Which year group are you in? Blank. Do you like the colours of the school uniform? Blank. What is your favourite colour? Afterwards, Lloyd thinks he should have given option boxes in question 1 and question 2. What could those option boxes be? So the reason for that is what he doesn't want is for one person to write the digit 8 in there and another person to write the word 8 in there. So by putting option boxes, 7, 8, 9, 10, 11. Doesn't say it's a secondary school, so it could have been year 4, 5, 6. Could have been a sixth form college, you could have put 12, 13, doesn't matter. That's what they're looking for, is a series of boxes with consecutive year groups. Say again, anyone? You wouldn't have to, but it mentions them. But if you, all they're looking for is that you're clearly separating the year groups. Okay? Question 2, do you like the colours of the school uniform? So once more, by putting option boxes in there, yes, no, he doesn't have to interpret the data. So yes and no is fine. Some people could put yes, no, other, where somebody might have an opinion. I like the blazer, I don't like the tie, that sort of thing. So that's what they're looking for you to do there. Interestingly, when I marked this paper, and hundreds of these, you'd be surprised how many students just wanted to answer the questions rather than, oh, I'm in year 11, no, I don't like the colours of my uniform, and my favourite colour is pink, rather than actually doing the maths part of it, which is to criticise it. Right, a pie chart displaying the results from question 3 of the questionnaire, what is your favourite colour, is shown below. Which colour was chosen by 75 pupils as their favourite colour? So 75 pupils out of, and then we've got to remember what that pie chart represents. How many people, how many pupils that pie chart represents. It's not 360, that's how many degrees is in it. Because we're dealing with the number of pupils here, not the size of the angle, it's out of 300 pupils. Okay? So 75 out of 300 pupils, if I figure that as a fraction, so if I go to my fraction button, okay, which is the one there my pen is pointing to, the square over a square, I put 75 over 300. Turns out that that means a quarter of the pupils. So which of those slices represents a quarter of the slice of the pie? Quarter of 360 is 90, which is a right angle, which is that one there, black. So 75 out of the 300, we write as a fraction. Use your calculator to turn that into an easier fraction, and then it's fairly straightforward to work out from there. Part 2. What fraction of the pupils said that blue was their favourite colour? So Meg, when I said at the start that you didn't need an angle measure, I lied. You do need an angle measure for this. Because in order to work out what fraction said blue was their favourite colour, you actually need to know what that angle is. So you know the whole pie is 360. So this is going to be some angle out of 360. So we need to measure how big the blue angle is. So you put the centre of your measurer on the centre of the pie, and you need to line up the 0 with one of the sides on your angle. Okay, so I've lined mine up with the bottom of the blue slice, and then I want to count up until I reach the other side of the blue slice, which is going to be 60. So I'm counting up, so I'm using the outside scale, 60 degrees. So the fraction of pupils that said that blue was their favourite colour is 60 out of 360. But give your answer in the simplest form. On a paper 2, this is easy marks, because your calculator is going to do it for you. 60 on top, 360 on the bottom, 1/6. So it's literally throwing marks at you. Right, so marks for question 3. So there's 1 mark for a group of questions where there's at least 3 year groups, so you've either 9, 10, 11, 7, 8, 9, but they have to be consecutive. You don't need the boxes, it's more important that you have the numbers, the year groups. And then for part B, yes, no is fine, YN is no, YN other, absolutely fine. Part B, part 1 is a straight B mark for black. And for part 2, there's 1 mark for the angle. Okay, so for measuring the angle accurately, and when I say accurately, it could be 2 degrees either side and you'd still get it right. So if you measured it at 58, 59, 60, 61 or 62, you would get that mark. Then there's a method mark for writing it out of 360, because the pi is out of 360, and a final mark if you've answered the question and written it in its simplest form. Question 4, time question. Now if you've practiced this button, okay, the time button, which is the one on your calculator which looks like a load of full stops and commas, this is such an easy mark. 3 hours 12 minutes. Right, we haven't on our formula sheet at the front, we haven't got 12 minutes, so that's no good to us. But we do know it's not going to be 3.12. So on our calculator, all we need to do is type in 3, time button, for hours, 12, time button, for minutes, press equals, and SD, and it turns it into, first of all, a fraction, then a decimal, 3.2. So there's another gimme mark there. If you know how to use your calculator, you can simplify fractions. If you know how to use your calculator, it does that for you. Part B. The first 40 miles of a journey took 1 hour 15 minutes. The remaining 80 miles were completed in 2 hours 15 minutes. Calculate the average speed. Right, that's one of my triangles. So if you can't remember it, we've already written it down. Speed, distance, time. So speed is distance over time. So for average speed, it's the total distance over total time. Well, the total distance is 40 plus 80, so that's 120. The total time was 1 hour 15 minutes and 2 hour 15 minutes, so that's 3 hours 30 minutes. 30 minutes, I can remember from the front, is 0.5 of an hour, so that's 3.5 hours. So I do 120 divided by 3.5, total distance over total time, and I get 34 point, and let's go to 1 decimal place. 1 decimal place would be 34.2 or 34.3. Look at the next digit, bigger than 5, so that's going to be 34.3 miles per hour. If you rounded it to 34, that would be fine as well. And if you used your time button, okay, you could have done that as 120 on top, and underneath 3 hours 30 minutes, and you get the same answer. So if you know how to use your your time button, and you remember you've got to press it twice, one to signal it's an hour, one to signal it's a minute, then that again is an easy question. So marks for that. 1 mark for 3.2, 1 mark for the 120 divided by the total time, however it is written, 1 mark for correctly turning that into 3.5, and 1 mark for 34.3 miles per hour. Okay, question 5. A newspaper report claimed the following: 12% of the world population is left-handed. Twice as many men as women are left-handed. 30% of the world population is mixed-handed. Mixed-handed people prefer to use the left hand for some tasks and the right hand for others. It is very rare to be ambidextrous, that is, being able to do all the tasks equally well with either hand. In 2011, Wales had a population of 3,063,000. In 2014, Wales had a population of 3,092,000. Calculate the number of left-handed people living in Wales in 2011. Well, in 2011, that was the population, 3,063,000. And I know that the assumption I'm going to make is if 12% of the world is left-handed, 12% of Wales is left-handed as well. So what I need to work out is 12% of 3,063,000. So depending on how your teacher deals with this, okay, I use the percentage button, which is above the open bracket. So all you need to do is type 12% times 3,063,000. So that equals 367,560 people. If your teacher prefers you to write 12% as a fraction, then you would do that and get the same answer. If your teacher prefers you to write 12% as a decimal, that's fine. Whichever way you do it, you're going to get the same answer. The assumption that you're making is that the proportion in Wales is the same as the proportion in the world. So the assumption is same proportion or same percentage of left-handers in Wales as in world. And that's all you can do. There's no other way you can work that out other than to use that 12%. In 2011, Wales had a population of 3,063,000. 1,559,000 of these people were women. In 2011, what percentage of the population of Wales were men, not women? So there's a couple of different ways of doing this, but I think what most people would do is first of all find out how many men there are. So number of men would be 3,063,000 less the women. So 150. So that's how many men there are. So to turn that into a percentage then, it's the number of men out of the total, which is 3,063,000. So that would give you the answer as a fraction, and then to turn it into a percentage, you times by 100. So use your fraction button, makes it neat. So 49.1%. And don't panic and think, oh, it's not a whole number, I've probably gone wrong. Okay, remember this is a calculator expected paper, so they expect you to be able to deal with numbers you have to round. So that's one way of doing it. The other way of doing it was you could have worked out the percentage of women, which would have been just the 1559 out of that, and then once you got that percentage, take it away from 100. So you could have done it in, either find the percentage and subtract that, or do it that way. So that's part B. Part C, how many mixed-handed people do you think were living in Wales in 2014? You must show you working. So if we go back to that information they gave us at the start of the question, 30% are mixed-handed. So I've got to work out what 30% of the Wales population in 2014 is now. So I'm going to be changing to this 3092000. But there is an important little extra command in the question. Give your answer to the nearest 1,000 people. So first of all, let's figure out what 30% of that is. So 30% times 3092000. And I'm going to write that out completely. I'm not going to round it off yet, because that 927,600 is going to earn me some marks. But it's not to the nearest 1,000, because the 1,000 is the 7, 927,600. So that number is between 927,000 and 928,000. So my answer is either going to be 927,000 or 928,000. Which one is it closest to? Well, because that's 600 at the end, bigger than 5 is going to push it closer to 928,000. So to the nearest 1,000 people, it's 928,000 people. Part D. A country of 6 million people meets all the claims given in the newspaper report. 8% of the women in this country are left-handed. There are 3 million men living in this country. How many left-handed men would you expect there to be? So you've got to go back now to this information, because all of a sudden we've gone from just dealing with left and right and mixed to men and women. So what does it tell us about men and women? It tells us twice as many men as women are left-handed. So if there's 8% of the women, there's going to be twice that of men. So rather than 8%, so if 8% of women are left-handed, then there'll be 16% of men are left-handed. Okay, so that's using this fact. I've just gone off the screen. That fact there, twice as many men as women are left-handed. So if 8% of women means 16% of men, and there are 3 million men. So to work out how many there are, it's going to be 16% of 3 million. And 3 million is 3 followed by 6 zeros. So for this last little bit, it's going to be 16% times 3, 48,000. Sorry, 480,000. So you're dealing with some big numbers in that question, but the maths is just percentages. So how are the marks awarded for question 5. So there's a method mark for the line of maths 12% of that, and 1 mark for 367560, and an explanation mark for the assumption you're making. And then for part B, there's a method mark for finding the number of men and writing it as a fraction, and an answer mark for 49.1%. For part C, there's a method mark for the 30% times the 309,2000, and an answer mark, for the 928,000 people. So if you just left it at that, you wouldn't get that second mark. And then for final part D, there's a method mark for realizing you're working with double the percentage. And getting the 16%, and then the method mark for finding the 16% of the 3 million, and an answer mark for the 480,000. So that gets us through all the E and D questions.